Now, considering this, how we are actually considering this? Basically, this is same as this. So probability of Q given D is basically probability of all the individual query words given the document. So what is the generation probability of the query term D1 given D? What is the probability of query term generation of query term Q2 given D? And so on. So all this probability generation, all these term generation probabilities are multiplied, and we are doing this assumption. I mean, we are doing this product based on this independence assumption. That is, no two query terms are being considered as occurring simultaneously or occurring together. So individually, all the query terms are being sampled from the document T that is being computed. So basically, if I draw the urn again, which is basically the document, and there are multiple terms in it, this is the document. And while generation of the query Q, what we are doing is we are computing the, so if Q is say Q1, Q2, what we are doing is we are computing the generation probability of Q1, we are computing the generation probability of Q2, and we are making a product of it. So probability of generation of Q2 and probability of generation of Q1. We are doing that based on this conditional independence assumption. That is, the presence of Q2 is computed, the generation probability of Q2 is being computed irrespective of seeing the or selecting the query term Q already from the same urn. Now here it is written in a different way. Earlier we are writing like this: probability of product over all the query terms in Q, probability of Q given D. Here we are writing it in a different way. How? We are considering that the query is K term query, and we are basically, for each of the query terms, we are basically computing the generation probability, which is essentially probability of Q1 given D into probability of Q2 given D, and so on, up to probability of Qk given D. Now let's say a query Q1, Q2, Q3, Q1, Q1. So there are three Q1s. Here it is basically, so basically there will be probability of Q1 given D. This will be present 3 times, isn't it? So this into this into this. So that's why, so it's not actually into 3, it is basically considered 3 times. Probability of Q1 given D, probability of Q2 given D, probability of Q3 given D, again probability of Q1 given D, probability of Q1 given D. So probability of Q1 given D 3 times for this, this, and this. So this we can write using this formula, where there are basically repetition when there is repetition of query terms in the query. Okay. Now, so basically, how many times the query term is occurring in the document, occurring in the query, is being put as the power, isn't it? So TF of QI, TF of Q comma Q is basically number of times Q is present in Q. This is basically TF of Q comma Q, which is in the power. So I hope this, right? All right. Now, the thing that we need to estimate is probability of Q given D. So given this document model, what is the likelihood that I'll be seeing this query term in the document? So in general, the generation probability of any term T from the document will be measured using maximum likelihood estimate. And maximum likelihood estimate says, following maximum likelihood estimate is basically an arm of terms. What is the probability that, if I draw a term out of the arm, what is the probability that I will be seeing T? It is basically the turn frequency of the term in that arm divided by the total number of terms in the document, or total number of terms in the arm. So probability of any, for any term T, the probability of generation of T given D will be computed using maximum likelihood estimate. So putting this together with this, what we'll be ending up with is basically this: probability of Q given D is equals to probably, so basically for all query term in Q, capital Q, note that this is basically unique query terms. Term frequency of the query term in D by the document length, which is basically the maximum likelihood estimate of the query term Q in the document D, which is again basically the probability of Q given D. So this is being approximated using MLE, and MLE is defined as this. And this is basically how many times the query term itself is occurring in the query. So this will be in the power. So this is in the power. So TF of Q in D divided by D to the power TF of the term Q in the Q. Okay. So as an example, if this is a document containing 9 terms, and basically, so 9 terms, which means length of the document D is 9 and 3 unique terms. Now considering this document language model, so this is basically the document language model. Considering this document language model, what is the generation probability of this query that is we will be computing? Now note that considering this, again, this bag of words approach, although this is a sequence, it is essentially 2 red, 1 yellow and 1 blue in no particular order. This is same as red, blue, red, blue, yellow, or say blue, yellow, red, red, or any other combination. So there is no ordering. So all we are ending up with is 3 query terms, one query term occurring twice and the other 2 occurring only once. So considering again the conditional independence assumption, the probability of generation of this from this document D, so this is basically the probability of Q document D, sorry, small d, will be basically this of red from the document square because it is occurring twice into probability of yellow into probability of blue. Now individually this probability of red, probability of blue, or probability of yellow or probability of blue will be considered, will be computed using maximum likelihood estimate, where it is basically will be computing the term frequency of red in the document by the document length. Document length is 9. Term frequency of red is 1, 2, 3, 4. So it will be 4 by 9 to the power square, basically square, due to the red ball being present in the query twice. That's why square. Any question up to this? Any question? All right. Then let's consider this scenario. The query is red, yellow, blue, green. Note that there is no green ball or green term in the document. Now, considering this maximum likelihood estimation based language model generation probability, or maximum likelihood estimation based term generation probability, this will be resulting into a 0, because for one term the query, so basically what will be this? Basically it will be TF of green in the document divided by the document length, and we know this is equals to 0 because green is not occurring in the document, right? As a result, as one term is not occurring in the document, it is being given a 0 score. Again, in other words, let's consider a queries containing k words. A document D will be given 0 score if any Q belonging into Q is absent in D. In other words, that is TF of Q is in the document is 0, which is a problematic scenario. Why? So let's say I am providing the query like say Indian Institute of Science Education and Research. Indian Institute of Science Education and Research, and say Science Education and Research Facility. So let's, for example, I mean, from this query, we can understand that the information need is someone wants to know the research facility or the facilities given to the IISER members. IISER, basically facilities. Facilities. Now, it might be the case that this term is not occurring in the document, but still there can be some relevant information that are being given in the, say, our homepage, our institute homepage. But facility, this term is not, say, present. Some other variation of facilities might be present. As this term is not occurring in the document, following this, we'll be getting a 0 score, isn't it? So following that, we need to basically address this some. In case of vector space model, this kind of an absence of a term would be reducing the score, not actually reducing the score, but for that query term, there will be no increment. That is, for VSM, the score of the query, the score of the document for the given query Q will be computed based on only the red ball, yellow ball, and blue ball. For the green ball, this part will be non-zero, but this part will be 0. Right? The query term, so where the query term is G comma Q, weight of G comma Q will be 0 because the term G is not occurring in the document. So as one term is absent in the document, it will be reducing the score, not actually reducing the score, but essentially the weight, the score will be computed based on the presence of the 3 query terms, or in other words, the score will be computed based on only the occurring query terms. The absent query terms will not be considered at all. But here it will be resulting into a 0 score, which is actually incorrect. Right?